Welcome to Session 3, Clear Fractions and Decimals. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to select an LCD that clears every fraction in one move, to scale every term of an equation consistently, and to convert decimal equations without mixing place value scales. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. The operation map separates denominator management from later equation-solving steps. The denominator stage is cleanup, not the solution itself. Trace each denominator to the LCD, then confirm that every term including standalone constants was multiplied by the same value. The key distinction is this. Select an LCD that clears every fraction in one move, and connect it to the second goal. Scale every term of an equation consistently. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. List all denominators and choose their least common multiple. Identify the object being changed and the requested result. Step 2. Multiply each complete term on both sides by the LCD. Use a separate line so signs, units, and restrictions stay visible. Step 3. Cancel denominators before distributing numerators. Work efficiently without skipping an operation. Step 4. Solve the integer equation and check in the original form. Whenever possible, verify with evidence independent of the original working. Signal 1 is several denominators. Respond by remembering, use one LCD rather than clearing fractions separately. Name the response before calculating. Signal 2 is term outside a fraction. In that case, it must still be multiplied by the LCD. The form tells you which tool fits. Signal 3 is decimals to hundredths. Remember, multiply every term by 100. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Solve 3x minus 2 over 4, x plus 1 over 6 equals 53. Restate the target and identify the most important part of the routine. The first move is, the LCD of 4, 6, and 3 is 12. This changes the form without changing the meaning. Next, multiply every term by 12 is to 3, 3x minus 2, 2 plus 1 equals 20. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Distribute. 9x minus 6 minus 2x minus 2 equals 20, so 7x equals 28. State what the transformed line tells you. Complete the argument. Therefore, x equals 4. Substitution makes both sides 5/3. This is part of the solution, not decoration. The final answer is x equals 4. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction. Substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. What LCD clears denominators 4, 6, and 3? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. F-focused hint. Choose the smallest positive number divisible by all three denominators. Use it to repair your setup rather than guess. An accepted answer is 12. Explain why it works and name the first step that would expose a common error. The central message is, select an LCD that clears every fraction in one move. Combine it with the discipline to scale every term of an equation consistently. Finish by remembering to convert decimal equations without mixing place value scales. This turns a calculated result into a justified answer. Reflection. Why is multiplying only visible fractions by the LCD not equivalent? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes with the LCD written before distribution. Keep the work readable, check it independently, and carry the routine forward.